Now, the first image from the world's most powerful space telescope, James Webb, is here.
Fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth.
The James Webb Space Telescope has once again delivered a revelation that ripples through both the scientific community and the imagination of anyone who gazes at the night sky. Among the many tasks assigned to this extraordinary observatory, its ability to track faint, distant, and fast-moving objects has now yielded one of its most startling findings. It has confirmed that the object designated 31 Atlas, a relatively obscure body catalogued only a few years ago, is on a direct collision course with Mars. This is not a minor adjustment to orbital predictions, not a loose speculation based on fragmentary data. It is a clear trajectory, a path that leads straight to the red planet. The discovery is remarkable not simply because it adds to the telescope's record of success, but because it thrusts Mars, a world already brimming with intrigue, into a new chapter of cosmic drama. Before we start, smash the like and subscribe buttons for more updates. The confirmation did not come lightly. Early telescopic surveys had already placed 31 Atlas among the many transient visitors of the solar system, suspected to be either a large asteroid or a cometary fragment. But the orbits were poorly constrained, leaving its ultimate destination a puzzle. Webb's infrared eyes, capable of tracing faint thermal signatures against the dark backdrop of space, provided the missing clarity. Over multiple observations, it tracked the precise drift of the body, calculating how solar radiation, gravitational tugs, and its own spin subtly altered its path. These refinements removed all ambiguity. What was once a wide corridor of possibilities has narrowed into a definite march toward Mars. The scale of 31 Atlas makes this revelation even more compelling. Unlike small meteoroids that pepper planets without much effect, this object is substantial, large enough to carve scars into the Martian surface and stir its thin atmosphere in dramatic ways. While Earth has experienced brushes with such cosmic projectiles, Mars is no stranger to them either. Its cratered surface testifies to eons of bombardment. Yet this time, humanity has front-row seats to watch an event unfold, with instruments already in place both orbiting and roving the Martian terrain. That transforms the encounter from a theoretical exercise into a live experiment, a chance to witness planetary impact dynamics with unprecedented precision. The implications for planetary science are vast. One of the central mysteries about Mars has always revolved around its geologic and atmospheric evolution. Its surface preserves evidence of once flowing rivers, sprawling lakes, and perhaps even a global ocean. But today the world is desiccated and cold. The arrival of 31 Atlas provides an accidental yet extraordinary natural probe. The energy unleashed by the impact will dig deep into Martian crustal layers, exposing material buried for millions or even billions of years. Scientists anticipate that the crater's ejecta could reveal minerals and ices untouched by surface weathering, offering direct insight into the hidden reserves of water and the chemistry of the subsurface. What would normally require elaborate drills or costly landers will instead be provided in a sudden violent burst. Another fascinating dimension is the atmosphere. Mars possesses only a tenuous veil of carbon dioxide, less than 1% the density of Earth's air, but that thin atmosphere is sensitive to disruptions. A massive object slamming into it will generate shockwaves, inject dust into the sky, and possibly produce temporary warming or cooling depending on the scale of particulate lofted. Webb's confirmation means that planetary scientists can now model these effects in detail before they occur. Mars orbiters, such as the Mars Reconnaissance Orbiter, MAVEN, and others, will be in perfect position to measure the chemical changes, track atmospheric waves, and record the dispersal of dust storms triggered by the event. This is a planetary laboratory of a kind that could never be manufactured, and its data will help refine our understanding of how atmospheres evolve when subjected to catastrophic impacts. There is also the question of Martian exploration itself. Over the past decades, rovers like Curiosity and Perseverance, along with the now silent Opportunity and Spirit, have slowly built a picture of Mars as a once habitable planet. But the collision of 31 Atlas raises both opportunities and risks for these robotic emissaries. Depending on the impact site, rovers could be showered with ejecta or enveloped in a haze of dust that limits their solar power intake and visibility. Conversely, new terrain features created by the impact could one day become targets of immense scientific value. If human missions are realized in the coming decades, astronauts may find themselves studying fresh craters born from this very event, sampling pristine rock layers laid bare by nature's violence. For theorists of planetary defense, the Webb detection serves as a reminder of the vigilance needed when tracking near-Earth and near-Mars objects. Though 31 Atlas poses no danger to Earth, its trajectory underscores how frequently planets are subject to celestial hazards. Mars has no system of deflection, no shield beyond its own gravity and atmosphere. The confirmation highlights the role of advanced observatories in providing early warning, not just for Earth, but for the entire solar neighborhood. Even though this particular collision is inevitable and unalterable, the lessons drawn from observing it could sharpen our strategies for averting similar fates should an object ever set its sights on our own planet. The composition of 31 Atlas itself is another subject of fascination. From Webb's infrared spectrographs, scientists have gathered clues about its surface, indicating a mixture of rock and volatile compounds. If it is indeed a fragmentary comet nucleus, its impact will not only crater Mars, but also deliver exotic materials, frozen gases, and organic molecules onto the surface. The role of cometary and asteroidal delivery in seeding planets with the ingredients of life is a long-standing question in astrobiology. To see such an experiment unfold on Mars, where the search for microbial fossils is already underway, will provide invaluable comparisons. Did ancient impacts of this nature once seed Mars with organics? Could 31 Atlas sprinkle new traces that mix with the old, providing a layered archive of chemical history? Webb's confirmation also invigorates the public imagination in ways that scientific findings rarely do. Mars has long been a canvas for human dreams, fears, and speculations. From early science fiction that envisioned canals and civilizations to modern-day blueprints for colonization, the planet has never drifted far from the cultural spotlight. The image of a cosmic projectile hurtling toward it evokes cinematic spectacle, but anchored in real physics. This sense of immediacy, the knowledge that a world we study so closely is about to be reshaped before our eyes, creates a global moment of shared anticipation. Unlike the countless impacts hidden in the deep past, this one is an event for the present generation to witness, analyze, and interpret. The technical aspects of Webb's role cannot be overlooked. Positioned a million miles from Earth at the Lagrange point, its instruments are not only designed for deep space cosmology, but also for solar system exploration. Its ability to lock onto a relatively small, fast-moving target like 31 Atlas demonstrates a flexibility that enhances the value of every hour of observing time. The telescope's sensitivity to heat signatures allowed astronomers to track the object even when it slipped beyond the reach of ground-based optics. This underscores the advantage of having space-based platforms with broad observational capabilities, ensuring that our understanding of the solar system is not confined to Earth's vantage point. Within the scientific community, there is already a surge of coordinated planning. Agencies are aligning their spacecraft schedules, adjusting orbits where possible, and prioritizing instrument readiness. Martian landers are being programmed to take atmospheric readings before, during, and after the impact. Orbiters are preparing for high-resolution imaging campaigns to capture the explosion and aftermath. On Earth, observatories large and small are expected to join in, tracking the flash of impact that may even be visible from millions of miles away. This international collaboration, sparked by Webb's confirmation, represents science at its most dynamic, responsive, united, and driven by curiosity. The scale of change 31 Atlas may inflict on Mars is not entirely predictable, and that unpredictability itself is part of the fascination. Crater size estimates vary depending on composition and angle of entry, ranging from a few kilometers across to something larger, an indentation that would rank among Mars's Great Basins. The shockwaves could trigger localized quakes, shaking the planet in ways that reveal the structure of its crust and mantle. Seismometers like those deployed by missions such as InSight, if still operational at the time, could capture the reverberations, adding a new layer of data to our understanding of Martian geology. In that sense, every aspect of the planet, from its deep interior to its high atmosphere, stands to be illuminated by this single event. Cultural and philosophical dimensions cannot be ignored either. The sight of one planet absorbing the blow of a wandering interloper reminds us of the fragility and resilience of celestial bodies. Earth, too, has been shaped by such events. The Chicxulub impact that altered the course of life, the countless smaller strikes that reshaped landscapes and climates. Watching Mars undergo a similar transformation becomes a mirror, showing us the processes that once sculpted our own world. It reinforces the notion that planets are not static spheres, but dynamic participants in a cosmic dance where encounters, collisions, and disruptions are not exceptions but rules. The timeline leading up to the impact is now a countdown. With Webb's confirmation, astronomers can calculate not only the when and where, but also stage a comprehensive campaign to capture it. For months, perhaps even years, anticipation will build as the object draws closer, its faint light brightening against the void. Mars watchers will see it approach in their data, the arc shrinking until planet and object become one. And though the event is distant in space, separated from Earth by millions of kilometers, it will feel immediate. An unfolding story written across the face of a neighboring world. The confirmation of 31 Atlas's trajectory is not merely an astronomical footnote. It is a narrative that combines science, spectacle, and significance. It invites us to think about impacts not as isolated catastrophes, but as integral parts of planetary histories. It positions Mars once again as a focal point of discovery, a world that continues to surprise even as we learn more about it. And above all, it reminds us of the extraordinary reach of our tools, of telescopes like Webb that expand our vision beyond Earth and allow us to see the unfolding drama of the cosmos with clarity and wonder. The countdown toward the impact of 31 Atlas on Mars has become one of the most riveting astronomical storylines in modern memory. With the James Webb Space Telescope providing absolute confirmation of its trajectory, the certainty of this event has shifted discussions from possibility to inevitability. What unfolds now is not speculation about whether it will happen, but rather how it will happen, what it will look like, and what doors it will open for knowledge. Each passing observation sharpens the picture of this incoming traveler, and every refinement intensifies the urgency to prepare for one of the most profound planetary-scale events humanity has ever anticipated in real time. The striking element of this situation is the clarity with which we can watch it progress. Centuries ago, when comets blazed across the skies, civilizations interpreted them as omens without any understanding of their true trajectories. Today, thanks to Webb and other instruments, we not only know exactly where this cosmic body is heading, but also how fast it travels, what materials compose it, and what energy it carries. The transformation from superstition to science is profound, and the upcoming collision with Mars embodies this shift better than any other celestial phenomenon. It is not simply a wandering fireball, it is a predictable, measurable event that bridges the gap between curiosity and comprehension. Every new data point enriches our understanding of 31 Atlas itself. Webb's sensitive detectors reveal not just surface temperatures but subtle variations that betray its irregular shape. The object is not a uniform sphere, but a rugged fragment, likely fractured long ago from a larger parent body. Its surface alternates between patches of reflective ice and darker rock, a mosaic that tells a story of ancient violence and cosmic wandering. The chemical fingerprints suggest volatile compounds that will vaporize dramatically upon contact with the Martian atmosphere, ensuring that the approach will be heralded by dazzling phenomena visible to both robotic instruments and telescopes across the solar system. Anticipation grows over what the actual impact spectacle will look like. As 31 Atlas closes in, it will begin interacting with Mars's thin air. Unlike Earth, where thick atmosphere burns meteors into brilliant streaks, Mars provides less resistance. That means the object will retain much of its coherence all the way to the ground, striking with tremendous force. Observers expect a fiery descent nonetheless, the heat generated enough to create a temporary miniature sun in the Martian sky. For a brief period, the planet will glow with light born from destruction, a reminder of the energy locked in even seemingly small cosmic rocks. Cameras aboard orbiters are primed to capture every second, ensuring that humanity witnesses the full sequence from entry to detonation to aftermath. This event also ignites questions about Mars's surface evolution on scales that normally defy human lifespans. The Martian landscape, already covered with evidence of past collisions, will gain a new feature in our time. For geologists, the fresh scar offers a benchmark against which to measure erosion rates, wind activity, and dust deposition. They will be able to watch in real time how the surface adapts, whether the crater rim collapses, whether winds rapidly blanket it in dust, or whether it becomes a permanent landmark etched into maps of Mars. The contrast between ancient eroded craters and this newly minted one will provide rare calibration for models that struggle to bridge billions of years. Equally captivating is the possibility of seismic reverberations. Mars has proven to be more seismically active than once thought, as instruments like InSight revealed before concluding its mission. An incoming body of the magnitude of 31 Atlas will send shockwaves through the crust, shaking the planet's interior in ways we can model but not yet fully anticipate. The waves generated will ripple through the core, mantle, and crust, carrying signals about density and composition. If seismometers are still operational, or if orbiters can detect ground displacement indirectly, the scientific payoff could be extraordinary. It would amount to a planetary CT scan delivered by nature itself, offering insights into Mars's hidden structure. The impending collision also stirs reflections on planetary vulnerability. Earth is shielded by watchful telescopes, coordinated space agencies, and developing defense technologies, yet Mars lies defenseless. The inevitability of 31 Atlas striking Mars highlights the reality that planets remain targets in the cosmic shooting gallery. Humanity's increasing ability to foresee these events underscores our technological maturity, but it also raises sobering questions about preparedness closer to home. Mars's fate becomes a demonstration of what could befall any planet if vigilance lapses. In this sense, the event transcends science. It becomes a stark rehearsal for what planetary defense truly means on a galactic timescale. Another dimension that excites researchers is the delivery of external materials to Mars. Impacts are not mere acts of destruction. They are also acts of deposition. Asteroids and comets bring with them exotic minerals, frozen gases, and potentially complex organic molecules forged in the depths of space. If 31 Atlas contains such ingredients, its collision will enrich Mars with material it would otherwise never acquire. The ejecta will scatter across wide areas, seeding the soil with cosmic chemistry. Future rovers or astronauts sampling these regions may find evidence of compounds critical to life. This natural transfer echoes processes thought to have delivered life's building blocks to Earth, and watching it unfold on Mars adds a tangible chapter to the story of panspermia. The social and cultural reverberations of this impending impact are already mounting. For the global public, Mars has always represented a symbol of both danger and promise. The thought of watching a cosmic object collide with it transforms scientific data into a shared experience akin to lunar landings or solar eclipses. Educational programs across the world are already mobilizing to incorporate live coverage into classrooms, using it to spark curiosity in astronomy, physics, and planetary science. Artists, writers, and storytellers too are poised to interpret the event through creative lenses, ensuring that its memory will persist in both scientific literature and cultural imagination. In many ways, 31 Atlas has become a bridge between the scientific elite and the everyday dreamer who simply gazes at Mars in the night sky. The coordination required to capture the event is also unprecedented. Spacecraft orbiting Mars will adjust their orbits and instrument priorities, ground observatories will synchronize observations, and telescopes like Webb and Hubble will be trained on the red planet at critical windows. This convergence of attention illustrates humanity's growing ability to act as a unified observer. It is a rehearsal for future large-scale astronomical campaigns where events are transient and every moment of data matters. The international nature of the collaboration also reminds us that space science transcends borders. Mars belongs not to one nation but to the collective curiosity of the species. Scientists are especially intrigued by how the Martian atmosphere will respond in the hours and days after the strike. Mars's sky is known for its vast dust storms, some of which envelop the planet for weeks. The impact of 31 Atlas could trigger such storms by injecting plumes of fine particles high into the atmosphere. Alternatively, the energy release could create local vortices, temporary weather systems that swirl and dissipate rapidly. Monitoring these outcomes will sharpen models of Martian meteorology, helping future missions navigate the unpredictable environment. For human explorers dreaming of living there, this data is invaluable. It helps predict whether impacts pose long-term climate hazards or localized disturbances. Another critical factor is the energy yield of the impact itself. Calculations suggest that the kinetic energy released will dwarf the most powerful nuclear devices ever tested on Earth. Such an event on Mars will melt rock, vaporize ice, and possibly create temporary lava flows around the crater rim. These features will provide geologists with a pristine example of how planets respond to high-energy impacts, allowing comparisons with ancient basins on Earth and the Moon. Studying these processes in real time gives planetary science a dynamic component usually reserved for theoretical models or laboratory simulations. The build-up to the event is already transforming how we think about time in planetary science. Normally, geology is the study of the immovable and the ancient. Mountains rise and erode over millions of years. Rivers carve valleys over eons. Yet here is an event that unfolds in minutes, delivering geological change visible on human timescales. To witness a crater form and then follow its transformation over years is to compress planetary evolution into something relatable. It allows humanity to see Mars not as a static museum of the past, but as an active, changing world still sculpted by cosmic forces. For Mars exploration programs, the collision forces a re-evaluation of priorities. Should upcoming missions focus on regions likely to be affected by the ejecta? Should they avoid those areas until dust settles? Or should they aim directly at the impact zone to capitalize on the unique science? These are not abstract debates. They are logistical decisions involving billions of dollars and decades of planning. The confirmation by Webb has provided time to adjust, but it also introduces new strategic considerations that planners had never factored in before. The Path of 31 Atlas effectively rewrites the agenda for studying Mars. The philosophical implications of watching Mars struck by a cosmic interloper are profound. It reminds us that despite our ambitions to colonize or terraform, planets remain subject to forces far beyond human control. Mars is not just a blank slate for human expansion, it is an active participant in a cosmic drama that predates us and will outlast us. The inevitability of this collision instills both humility and awe. Humility, because it reminds us of our smallness against celestial dynamics. Awe, because it shows us the precision with which we can now foresee such monumental events. The balance of those emotions creates a narrative that resonates far beyond science. It speaks to our place in the universe. Webb's role in confirming the trajectory will be remembered as a defining moment in its legacy. While much attention has focused on its deep-field images of distant galaxies, the telescope has also proven its worth as a guardian and observer of our own solar system. The success in tracking 31 Atlas cements its versatility and ensures that future missions will rely on it not only for cosmology, but also for planetary monitoring. It has become a bridge between the infinite past of the universe and the immediate future of our neighboring planets. As the date of impact approaches, excitement will mount across disciplines and societies. Scientists will sharpen models, children will learn about planetary dynamics, and enthusiasts will watch the countdown with anticipation. The world will share in the spectacle of Mars being reshaped before our eyes. And when the moment comes, when 31 Atlas slams into the Martian surface, it will not merely be an astronomical event. It will be a chapter in the ongoing story of exploration, discovery, and the eternal dialogue between humanity and the cosmos. The impending arrival of 31 Atlas on Mars stands as a milestone not just in astronomy, but in the story of human awareness itself. Every element of the event, from the object's uncertain beginnings to Webb's precise confirmation of its path, draws our gaze toward the richness of planetary processes. Now, as the countdown continues, scientists and observers are turning their focus toward areas of study and interpretation that go beyond immediate impact mechanics. They are asking how this event integrates into larger frameworks of planetary evolution, interplanetary exchange, and even the future of human settlement beyond Earth. Each layer of inquiry deepens the sense that what unfolds on Mars will ripple outward into nearly every corner of scientific thought. One of the most significant questions raised is how impacts like that of 31 Atlas might influence long-term climate cycles on Mars. Unlike Earth, where oceans and a dense atmosphere buffer drastic swings, Mars is far more sensitive to abrupt inputs of energy and dust. Even a single collision can tip delicate balances. If fine particles from the impact plume remain aloft for extended periods, they could block sunlight, cooling surface temperatures in already frigid regions. Conversely, if certain volatiles are released, especially carbon dioxide or water vapor, they might enhance localized greenhouse effects. This tug-of-war between cooling and warming is essential to predicting how Mars's environment might change after such an event, and it has direct relevance for those planning long-duration human missions. The idea that 31 Atlas could unlock subterranean secrets also continues to inspire. Mars has long intrigued researchers with hints of underground ice sheets, saline aquifers, and possibly even geothermal reservoirs. The violence of the collision will crack the crust, opening pathways into regions previously sealed. These newly exposed layers might reveal chemical signatures of past habitability, or even trapped gases that tell stories of ancient atmospheres. For astrobiologists, this is a tantalizing chance to analyze Martian geology in its rawest form, unfiltered by the erosion and radiation that typically weather the surface over millions of years. An impact-created window into Mars's deep past could prove more revealing than any carefully drilled borehole. Another dimension of immense interest lies in comparative planetology. Earth, Mars, and the Moon all carry scars of massive impacts, yet we rarely get to observe them in the act. By studying how 31 Atlas reshapes Mars, researchers can better interpret what similar collisions did to Earth in its early days. Some of those ancient events delivered water and organics, potentially paving the way for life here. Others were catastrophic, reshuffling continents and climates. On Mars, with its thinner atmosphere and different crustal composition, the outcome will differ. But those differences themselves are instructive. They provide a living laboratory for testing hypotheses about planetary resilience and vulnerability under bombardment. The impact will also feed directly into the discipline of exoplanetary science. Beyond our solar system, astronomers routinely detect debris disks and observe signs of collisions in distant star systems. But these observations are distant and indirect. Watching a large object collide with Mars allows researchers to calibrate their interpretations of such faraway events. If a collision on Mars produces certain atmospheric signatures, such as spikes in dust, gas release, or temporary brightening, scientists can look for analogous patterns when studying alien worlds. Thus, 31 Atlas is not just a Martian phenomenon, but a Rosetta Stone for decoding planetary violence across the galaxy. Attention has also turned toward technological spin-offs. Preparing to monitor this event demands innovations in imaging, data transmission, and coordination across instruments. Space agencies are refining algorithms that can track fast-changing phenomena and transmit data without delay. These technologies, once perfected, will be repurposed for other missions, whether they involve asteroid mining, lunar exploration, or deep space probes. In this way, the impending collision indirectly accelerates the pace of human expansion into space by forcing engineers and scientists to push the limits of what is currently possible. On a human level, the confirmation of 31 Atlas's path has fostered a profound sense of planetary kinship. Though the object targets Mars, the narrative resonates on Earth. Discussions about the fragility of worlds, the inevitability of cosmic impacts, and the necessity of preparedness are universal. Many have begun to frame the event as a shared moment of cosmic citizenship, a reminder that all planets occupy the same vulnerable role in the larger theater of the solar system. For people who dream of building a future on Mars, the collision becomes a symbolic reminder that colonization will not occur on a blank canvas. Instead, settlers will inherit a dynamic and sometimes hostile environment, shaped not only by dust storms and cold nights, but also by the sudden intrusion of wandering bodies like 31 Atlas. The artistic responses to this discovery are already proliferating. Writers, visual artists, and filmmakers are envisioning how the Martian horizon will glow during the descent, how the surface will shudder upon impact, and how rovers might capture the drama in eerie silence. These creative interpretations are not distractions from science, but amplifiers of its reach. They ensure that the story of 31 Atlas belongs not only to laboratories and observatories, but to the broader human narrative of wonder and awe at the universe. Just as the Apollo missions inspired generations through art as much as through data, so too will this Martian collision leave cultural traces that outlast the immediate scientific harvest. Speculation has also arisen about the role such events might have played in shaping Mars's potential for habitability in its earliest epochs. Billions of years ago, when impacts were more frequent, each collision may have delivered essential ingredients for life, or triggered temporary warming episodes that allowed liquid water to flow. By watching 31 Atlas strike today, scientists may infer how similar events contributed to the cycles of wet and dry eras visible in the Martian rock record. This modern event becomes a time machine, echoing the processes that once defined whether Mars was merely a cold desert or a cradle for microbial ecosystems. Another overlooked yet fascinating aspect is the possibility of impact-induced magnetism. Mars lost its global magnetic field long ago, but localized magnetic anomalies remain in its crust. A sufficiently energetic impact could potentially remagnetize certain regions by heating rocks past critical thresholds. Though speculative, this offers another avenue of investigation. Could impacts intermittently recharge planetary magnetism, even in limited zones? Such questions reveal the depth of inquiry sparked by what may seem at first glance to be a single destructive event. Educational institutions are seizing the moment as well. Curricula are being updated to include live tracking of 31 Atlas, with students encouraged to model trajectories, calculate kinetic energy, and debate the philosophical implications. For a generation raised on distant, abstract space exploration, this collision provides immediacy. It transforms equations into lived experience and theories into unfolding reality. In the same way that eclipses and meteor showers inspire public gatherings, the anticipation of this Martian event is drawing communities together in a collective act of cosmic observation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 31 Atlas possibly colliding with Mars soon? We want to hear from you. Thank you for watching and see you next time.